Hello everybody, it's Andy here from AM Media Games. In today's video I'm going to be showing you how to create a puzzle kind of like rotating tower, something that you'd get in kind of like games like Uncharted, Tomb Raider, stuff like that, where you kind of, yeah, I know it's three white squares, it's just placeholder models, but yeah, so kind of like when you walk up and you've got different patterns on each side, and you have to figure out, maybe there might be one, two, or even three of these, and then you have to figure out how to figure out the puzzle of which way they should all be rotated. So the main reason I'm making this tutorial today really is because I've just been implementing this into my own game, and I did say that any puzzles that I create, then I'll be sharing them with everybody over on YouTube, so people can also learn along and pick up some ideas of their own. So you can see on the left side of the screen, just for teaching purposes, I've got the readouts for the rotation angles of each individual cube. So you can see there at the top left now, it's after the second click, it's at 108 degrees. If I do it again, you can see there that it's changing now. It's minus 90, and then once more it's back to 0. And there is a little tiny bug which I'll mention when I get into actually creating the blueprint. So if you want, you can skip ahead if you like, or you can kind of watch the full video and learn. It's entirely up to you. But yeah, so there is a tiny bug in Unreal, and you can see here that it's actually showing itself straight away, which is great. It now says 179.9 degrees. This is a precision issue, but there is a fix in the terms of a node that will allow you to have kind of like a value that you can set for. I'll show you. So I'll open up this blueprint, but I'll go through it all. So down here we have a nearly equal, and we have an error tolerance level. So this is a double float precision, and using this method we can kind of fix that bug, that glitch. So even though every time I'm rotating this object it's adding 90 degrees each rotation, you can have it add 30, you can do 10, you know, you can have multiple faces, you can have as many faces as you like, and you can just rotate it in degrees. You can make this physics based, so you click and drag and you'll move it that way. There's lots of different ways to do this, but there is a little bug, and luckily enough there is a node that will allow us to have kind of a tolerance zone, so we can be a degree slightly off or a degree over, 0.1 degree, and it will kind of fix that bug. So let's recreate this together now, and I'll show you how to set this up. So there's going to be a couple of links in the description, so this is an important part of the video. Please look at the description of the video. So before you post a comment saying, oh, how do I interact with it, it's not working, I'm using Blueprint interfaces, and I get a lot of questions saying, oh, this isn't working for me. Well, it's not gonna work for you if you don't have a Blueprint interface. So please make sure you read the description of the YouTube video. I will put all of the necessary links in there, because this is a progressive tutorial. This is not the first step, this is like the third or fourth step. So I'm currently developing a game. This is not the beginning of the game. I'm creating the puzzles at the moment, I'm creating assets, and I'm putting them all together to make a finished piece. So this is kind of a little bit further ahead. This isn't the start. So if you read the description, there will be all of the information you need. So with that important part of the information over, let's move on, and I'll show you how I set this up. So in here I'm going to right click, I'm going to make a blueprint class, actor. I'm going to name this one a tutorial rotate puzzle object, just so I know which one to delete. And we're going to drag that into the level, so we can see here that we have our actor, and now we just need to add these cubes. So we're going to open it up, and we can do that here. Excuse me. We can click on edit tutorial, which is the one I just created. I'm going to get rid of the other one, pop that into there, and we're going to add some cubes to this. So let's go here, add, and then we'll go cube, and then we'll click cube. We'll drag that up. Let's move that up so it's touching the floor. So where the bottom, where this grey line is here, in your level, that will be where the floor mesh will be. So if I show you what I mean, if you compile that, the default position when it spawned it in would have been like this, and if you go into the game you can see it goes under the floor. So what you want to do is kind of have it like it's, imagine this grid, well, don't imagine, this grid is the floor, and you can actually activate it up here as well, show floor, but sometimes it just doesn't work. Okay, so you want to move this up and then kind of align that with that green line, just like so. And then if you go into your game, you can see that it's just on the floor, which is perfectly fine for us. That's all we want. Then we want to shrink this down as well. So let's shrink that down, just like this. Yep, that'll be, oops, that'll be perfectly fine. Let's move it down a little bit, and then we can copy this 2 more times or 3 more times. You can make as many of these as you like, as long as you know that your player can reach the top one. So we're going to copy this, Control C and Control V, and then we're just going to move it up. So let's have a little bit of a gap between them. Obviously you would replace these with your working mesh. This is just placeholders. So we're going to Control V again and then move that up, just like so. So we have a difference here, clear excuse me, a clear difference here between each mesh. We've got 3 cubes. I'm going to name them now. So this is going to be bottom. It's important to name these, otherwise it will get confusing. Middle, and we've got the top. So top. So to name that, if you click on it, you can either double click or you can click and press F2, which is the shortcut key for everything to rename. So if you click and press F2, it will open up the rename box, so you can put in whatever you like. So now that we've got that done, we need to scroll down and just make sure it's on block all dynamic and world dynamic, which it is, and it is, and it is. And we're also going to give these tags. So we're going to do that now. We're going to give them the same tag of the name of the object. So we're going to press F2, Control C, then click on it, type in TAG in the details bar on the right side. Where it says component tag, we're going to give these specific tags, so they have different actions for each one. And when we use our line trace system inside of our event graph, it will enable us then to aim at each one specifically and only interact with those ones specifically. It won't turn all of them at the same time. So in our components tags, we're going to click add. We're going to do that once, and we're going to name bottom the same one. So we're going to Control V, and then that one's done. Then I'm going to click on middle, press F2, Control C, add a tag, and then Control V, middle. Make sure it's exactly the same, case sensitive, spelt the same and everything. So F2, Control C, add one tag, and then Control V, then compile it. So now each one of these has a tag. Bottom has bottom tag, middle has middle tag, and top has top tag. Top tag. Right, okay, so event graph. In here, we're going to keep event begin play because we're going to utilize it in a short while. Now we're gonna cast to the player character. I don't usually use these, but I mean the only time it's really going to cause a lot of problems is if you're using these hundreds and hundreds of thousands of times per frame. You're going to notice some performance problems and hitches. But if you're going to use them every now and again, it's perfectly fine. Just don't get in the habit of constantly casting to the player. Try and utilize different methods. It's not the end of the world if you do. It's just one of them things. So we're going to drag out. I'm going to cast to. Mine's going to be first person character. So I'm going to get first person character. This is going to be get player character, just like so. Just like this. We're going to select these two, press Q, bring that there, and then we're going to right click, promote to variable. This is going to give us the reference variable that we need. We're going to name this one character reference, so we know what it is. Character reference. And then what we're going to do now is we're going to create a line trace. Now I'm using a Blueprint interface system. Now the links in the description will explain that. I've got a video which will show you, when you're just starting out on Unreal Engine, how to set up an interface, how to interact with Fedora, and how to read notes and stuff, interact with different objects. So I will post that in the description, and if you struggle, feel free to leave a comment, but please at least watch those videos first so you understand. If you struggle with it, it's fine, you can ask away in the comments. I'll always try and help people. So we can get rid of this tags and the details. We're going to drag this into our graph, get. So now we have our character reference node, and with this node we can now access everything inside of our first person character blueprint. And what we want to access is our first person camera. So first person camera. So we're going to get our first person camera, and then what we want to do is we want to drag out and get world location. We want the location of our camera so we know where to start the line trace from, and we also want to get the direction the player's facing. So we're going to get a forward vector. So this is the direction that the player's camera is looking, so the forward direction. So we're going to get a forward vector. I'm going to move these down a little bit. Try and keep things nice and tidy so it's easy for you to follow along. Out of this one, we're going to get, excuse me. excuse me. Right, okay, so out of this one, we're going to get a multiply. So we can click on the star key on the numpad, and we get a multiply. Then out of this one, we're going to get an add. So just click plus and then click enter. We're going to swap these around. So we're going to go into the bottom. So we're going to go from the multiply output, we're going to go into the B input of the add. What we're going to do next is we're going to get the world location. I'm going to plug that into our add node. I'm going to right click here. I'm going to make this a single precision float. I'm going to put 200 in there because that's the distance that it's going to draw the line from the camera in a forward direction. So we're going to get the forward direction, we're going to add 200 units in front, so around 200 centimeters, and it's going to draw a line from the player 200 centimeters in front, and then it's going to hit an object and give us a reading or perform an action. So in here, I'm going to go to my class settings, I'm going to go down to implemented interfaces, and I'm going to use my use open close blueprint interface that I created. So the very important part of the information is this is what I made, this is what I named it. Whatever you named yours is what you would need to use. If you named yours use open close, then it's going to be the same. If you named yours something different, it's not going to be the same. Right, so use open close, compile, double click on that, it's going to bring it into our graph. And then out of here we're going to get a line trace by channel, just like so, and the plus is going to go in end and the world location is going to go in start, just like so. Excuse me, apologize for my cough. The more I talk, the more I cough. So we're going to get a branch, hold B and left click, connect that into there. The condition is going to go into here. We're also going to get a break hit result. So we're going to drag out of our out hit, and then we're going to click just here. You don't need to type anything, it's just underneath. Break hit result. We're going to click the drop down box. And we can see here that we have all of these really cool options for different types of interactions on the line trace. So something like this one will be used for footsteps. So if you want to use dynamic footsteps, you draw a line from the player downwards, and then when it hits the different materials, physics materials, you would have different sounds. Hit actor would kind of look out more for an actor. Because these are components within an actor, we can use hit component. So we're going to drag out of hit component, and we're going to get component has tag. Now remember earlier in our in the start of creating this blueprint actor, we created tags. This is where they come into play. This is where they're important. This is where their use comes in. So what we're going to do is we're going to try not to cough. So I'm just going to drink some water. I'm going to try very hard not to cough, so I apologise. We're going to copy this 2 more times, just like so. Excuse me. Hit component is going to go in there and in there. So we've got 3 of these, just like this, and we then need to add a branch. And we need to add another branch. And another branch. So we're going to have 3 components, 3 branches. This first branch, this one, is going to connect from true into the input of the second branch. The false into the third branch, and the false into the fourth. Oops. So first branch coming off the line trace goes from true to input second branch. The second branch goes from false to input on the third branch, and then the false from the third branch goes into the fourth one, just like this. So I'll pause it there for a second, make sure you got that set up. Component has tag 1 here, is going to go into the condition. This one's going to go into the condition of the third branch, and this one. So you'll have it kind of set up like this. So you've got 3 components have tag and 3 branches. Each one has a condition, and each one is a component has tag. Excuse me. I'm going to go on to bottom. I'm going to press Control A, select all, Control C, and we're going to paste that in there. We're going to go to the middle, copy, and paste. And top, copy, and paste. Bottom tag, middle tag, top tag. Okay, so now that that's done, what we need to do is add our code which is going to rotate our objects and give us the movement that we need. We're going to set 90 degrees on each click. So to do that, let me just turn my phone on silent, 1 second. Okay, so to do that, we need to add a few things, but we also need to get some references. So let's drag, which is bottom. So the bottom one's going to go down here, the middle one is going to go here, and the top one is going to go here. So out of top, we want to get relative location, this one, because we want to get the current location of our object. So let me get rid of this one. We want to get the current location of our object. If we don't do this part, when it comes to rotating the object, you'll click on it and the component will vanish to another realm. It'll just move. So we need to tell the blueprint where its current location is, so we don't move it from that spot. We only want to rotate it in its current position. We're also going to get a get world location, get world rotation, like so. I'm going to split struct pin, and then we want to, so what we're doing is we're getting its current relative location in the world, we're getting its current rotation value, and then what we want to do is add, so we're going to drag out and add 90 degrees to it. So whatever its current position is, which will be 0, 0, 0 on the rotation. So whatever its current position is, it's going to then add 90 degrees to it. So it's going to rotate this by 90 degrees each time we click. And then we want to make rotator, just like this. Oops, that one. And that's going to go into the bottom, Z, for the yaw. Let's move this here and here. And then out of this one, we want to split struct pin, and we only want to control the yaw value. Okay, so that's done. Out of here, we're going to get a do once. So we're going to get a do once, hold O for Oscar, and left click. Out of this, we want to get a play sound. Actually, we can add a sound effect here. So we can do add audio. It's an easier way to do it. This is going to be rotate sound. And then in here, you would put your sound file that you wish to have play when you rotate the object. So in the other one, I had like a stone on ceramic plate kind of grinding noise. So all you'd do here would be to add your sound effect here. So then whenever you click rotate on the object, or whenever you interact with the object, it will make that sound as it rotates. Your branch from the true is going to go into the do once, just like this. To get a reroute node, just double click anywhere on the line, and it will add a little tiny pin that you can use to reroute your trace lines. Get these two just like so. And the next thing we want to do is get a move component. So we're going to grab this, copy it, and paste it. Drag out, move component. Component 2. If you go down to the bottom, we have a move component 2 node. This is going to enable us to have a nice smooth transition where we can set the time value. So we're going to, over time, which is the amount of time it takes to move the node, move the object, we're going to put as 1. And then in here, you can see here we have our relative location. That's going to go into our current location, just like this. That's going to go like that. That's going to go here, nice little top hat. And then completed. It's going to go into our play, so we're going to get a play, and then that's going to go into here, and that's going to go into move, just like this. So this is how it should look. We're going to add a delay at the end, just so we can make sure there's no bugs, and out of completed, we'll go into the reset for the do once, and then we can just add a reroute, just like this, make that nice and tidy. So when the player interacts, if the component that the player is currently looking at has the tag top, then that would be true, so then it will fire this code. If the component that the player is looking at does not have the tag of top, then that would be false, and then it'll do that same check. If the component has a tag of bottom, so it's not middle, then it'll go to false, and then it'll do the same check here. So it's just like a little relay. It's checking, oh, it doesn't have top, it doesn't have middle, oh, it has bottom, so true. If it comes out of false, nothing will happen. Just do it all over again. So we're going to then make sure that we add in our rotation. So here we can split struct pin for our rotation, and then we're going to drag yaw into yaw on there. And we're going to ease in, ease out, leave it as 1 second. You can have it take longer if you like. Completely up to you. Whatever time you put in here is however long it will take for it to rotate. Excuse me. So that's that done, and the easy part now is just we can control C. So we're going to take these ones, we're going to take all of these ones and this one, and we could probably even do those just like this, and even that. So we're going to control C, I'm going to paste, and then we're going to move all of this up a little bit, just like so. Move all of these up a little bit, give some space. So that's that one done. And then this one here, we can do this one for this one, which is fine. Just connect that there like that. This is going to go here, that's going to go in there, that's going to go in there. Move that down. We're going to take this one, Control C, Control V, and put bottom into component. So all we've done is copied the necessary nodes we need, and then hooked up our reference to our parts, so bottom, middle, and top. So this one's bottom, and this one will be middle. So we can move all of this one down, just like so. Grab these two, move them out a little bit, and then if we Control V, oh no, yeah, we need to copy them again. So take all of these, this, and this little one. Control C, Control V, just like so. And then that's a really easy way to set that up. Connect those in there, copy that, paste it. That's going to go into our target for our move component, and then that's going to go into true. So this one up here is going to be our top, so we can comment this top movement control, and then the one here is going to be our bottom movement controls. Move that down a little bit, and then in the one in the middle is going to be our middle movement controls. Right, so that's all done. So technically now, making sure I've got all this set up correctly. Yeah, if we go into the level and click, let's make sure I'm hitting the object. Let's have a quick look. Have a look. There we go. So make sure we uncheck ignore self. I did forget that. And you can see here that when we click on the object, we have a nice smooth rotation. We can slow that down. We can set this if you want to 2 seconds. Just to see what that looks like. There it is. So you've got good control there about how long it'll take. So you can see there over 2 seconds. So 1, 2, and done, with the 0.5 at the end to stop it from being spammable, and also just to reduce the chance of it breaking. So now we have a rotational panel, but how do we make this into a puzzle? So what we need to do is come up with some kind of way to monitor its rotation, and then add an event or a dispatcher to kind of listen out for when that rotation is correct. To do that, we need to add a little bit more code underneath. So we're going to go into our blueprint. So on my other screen, I've just got some notes written down just to keep my mind from getting sidetracked. So we're going to go into our blueprint that we've just created, and we can see here that we have our line trace working fine, and we've also got our movement code all working fine. We have our little reference there to our player, so we can call the camera. So we're going to comment this. This is going to be our line trace for interaction code, and then this is going to be our get character reference. So we can increase the size of the writing as well. Let's set this to 32 and do the same on this one. And you can color code things as well as you go. So this will also be 32, this will also be 32, oops, and this will also be 32. So if you wanted to, you could make these ones red, and it'll give you an idea of, or it'll stand out more for you when it comes to making your code. So we're going to go to a little space underneath, just about here, And we need to create a timer by event. And to do that, we can do set timer by timer by event. Yeah. And then we're going to create a custom event just like this, and this is going to be our get rotation values, and that's going to delegate into delegate. There we go, just like this. Now out of this we're going to get 3 print strings just so we can see what we're doing. So we're going to copy that, print string 1, 2 and 3. Now a print string is a really good way of debugging code, figuring out what nodes do and giving you an idea of whether or not something's firing off or working the way it should. So try and get used to using them. Make sure you take them out for when you package your game though. Yeah, you don't want to leave them in. Excuse me. So we're going to get references to our 3 nodes, just like so. And click all 3 and drag them in. I'm going to get world rotation. I'm going to split this. And we're going to copy this node 2 times. Just like that, just like that, just like that. So that one can go there, that one can go there, that one can go there. Move these over a little bit. And out of the z, your value are going to go into our strings. So I'm going to 1, 2, and the final one 3, just like this. That goes into there, that goes into there, that goes into there. So get rotation value, custom event, set timer by event, set it to looping, set the time to, let's say 0.5, so it updates every half of a second. And that's going to go all the way through these into a branch. So hold B for Bravo and left click. We're going to get an AND boolean. So AND bool, this one here at the top. We're going to add another pin because we have 3. And we're going to get a nearly equal float. We're going to copy that 2 more times. The Z is going to go into the A of each one, just like that. So Z, you're into A. So you go reference, get world rotation, split struct pin. Excuse me. Split struct pin, you're into A of the nearly equal, and our tolerance is going to be 1 degree either over or under. So an error tolerance is how many degrees of error we can have in the rotation value that will still allow us to have a positive true result. I hope that makes sense. So we're going to have 1 degree over or under is an acceptable radius. You're probably never going to go 1 degree over unless you don't have the delay and or you use a different method of moving. So if you don't remove the ability for the player to spam the code, then you're going to have a serious issue with the rotation. So we can compile it. Let's go back down to what we were setting up. So in here right now, this is going to be calling, well, this is going to be doing nothing because we need to call this. But in here right now, this is going to be calling our rotation value, and then it's going to be comparing the rotation that we set here. And when it's nearly equal or equal with a 1 degree of tolerance either side, then it will return a value of true. So connect all of these into the AND, then get your branch and connect that into condition. So you're going to go like this. Get world rotation. If the rotation is equal to what we set in the B value, so you can see if you hover over A, you'll see there you've got your float double precision, current value equals 0. And then float double precision here, this is going to go, okay, so if it's equal to 90 degrees with a tolerance of 1, then that's true, send a signal, but wait, I can't do anything because these also need to be true. So you set this one to 90 degrees and this one to 180 and this one minus 90. When they're all matching, then the AND gate will allow this to happen, then the true will call our event. So we're going to use a play sound at location. Play sound at location. And the sound, I'm just going to use a click noise. There you go. This would be an event dispatcher. So this is all conditions met, allow event, and then we can drag that in and call. So in our level blueprint, if we have a door or you have some form of a puzzle set up and the conditions have been met, then you can then call an event in your level blueprint, and then you'll be able to open a door or open an object or reveal, I don't know, a puzzle piece or something that happens. Maybe it be a cutscene. So whatever happens, you're then going to be able to call this event. You don't have to name it the same, but this is just a way of doing it. So when these match, so let's set in this one, we're going to go with 90. In this one, I'm going to go with minus 90. And on this one, I'm going to put 180 degrees. We're rotating by values of 90, so it's always going to be one of these. It can either be 90, 180, minus 90, or 0. Can't be anything else. We might have a slight error tolerance, where it could be like 89.99998. You've probably seen that in your level when you rotate an object, and when you go to the transform, it will say like, what are you doing, dog? Are you trying to get attention? Because I'm talking to the microphone. Yeah, you are. Okay. So you've probably seen it here in the rotation variable where it says 89.9. That's the tolerance issue that I was talking about. So let's go into the game, but let's comment this. Check rotation for match. If true, then allow puzzle completion. I've just spelled that so wrong, I think. Yeah, I have. So we're going to set that to red. We're going to change to 32. What the hell? Okay, so we also need to call this event. So let's go to our event begin play at the top. This is where this comes into play. No pun intended. And I'm going to get our get rotation value here. I'm going to drag that on. So this is going to call that event to start, which is then going to start processing to check to see what the rotation values are. So if we go into the game, you can see there on the left, the top left side of the screen, that's our print strings working. And then if we click, we can see here that we have a rotation. And we have 90 degrees on the top, 90 degrees on the bottom, and then 90 degrees on, middle, and then 90 degrees on the bottom. So they're all currently on 90 degrees. We want to match this to 90 minus 90, 180. So we're going to go 90, and then we're going to do 3 clicks. 1, 2, and then 1 more. And minus. Yep, and then minus 90, or was it 90? Which one was it? Let's have a quick look. 180 degrees. So 90 minus 90, 180 degrees. So 90 minus 90, and then we want 180 degrees. Let's see if I've done it in the right way around. So top Oh, okay, sorry, yeah, I've done it wrong way around. So top 180 minus 1990. So I'm even crap at my own puzzles. So 180 in the top, and then it was minus 90 in this one. This one was 90, so this one needs to be minus 90. Was that right? Did I get it wrong again? So 180 minus 1990. 180 minus 1990. Oh wait. 180 minus 90. Yeah, okay, don't judge me. 180 minus 90. And then 90. This is that part where you can all laugh because the guy can't even figure out his own puzzle. What did I not connect? Let's have a look. So let's switch these around. Confusing the hell out of me. So we're gonna go middle there, top there. So 90 minus 90, 180 degrees. Compile it. Let's double check. 90 minus 90, 180. Okay. 90 minus 90 and then 180. There we go. So yeah, so that works. So now that that is set to true, and because now, sorry it took me so long to figure out my own bloody puzzle. I confused myself by setting these the wrong way around, so that didn't help. So play sound at location, you could hear that was triggering. You got the clicking the button, sound playing, and this means that we can now call this event in our level blueprint. So in your level blueprint, you can get a reference to this. So let's show you what I mean. We'll keep that one. We're going to get a reference, and we name that to call all conditions met. So bind event all conditions. So you can see here, bind event all conditions. We're going to get a custom event, add custom event, and we're going to plug that into there. If you're using this already, what you can do is you can create a custom event, call this one bind events, plug that into there, and then on your event begin play, let's say you've got loads of stuff, you can just drop that on anywhere in the order as long as it's on the event begin play. You don't have to use event begin play. You can bind the event off another event. So as long as it's calling this is going to go into here. Now in our puzzle we have all conditions met. When these conditions are met for the puzzle, for the rotation, this could be like a number on a lock. Sorry this video is taking so long. It's not. It's supposed to be long. It's kind of more of a detailed explanation. So once all the conditions are met and you've got your branch, which then is true, when you heard it play the sound, this is now being basically this can now be called. So in here, in our level blueprint, we can see here now bind event. So we've bound the event has been called here, and this is the event in our level blueprint that we want to bind it to. So let's say you have a door actor blueprint and you only want it to be able to open when this condition's met. Now you would put that here. So you'd get a reference to your door, right click, get reference to, and then search for your event inside your door blueprint, and then you would put that there, open door, out of this with your reference. Another thing you could do is like play a level sequence. Maybe have a group of events that you want to happen. Maybe you unlock new armor or something. I don't know, whatever is going on in your game, you would set that all up here. So this is how you would do that. I might put this in a separate tutorial, but I hope this helps. I hope people find a really good use for this. This will be in my game when it's released. I'll probably get stuck playing it because I'll probably forget what the what all the rotation values are. But the rotation values could be shapes. So you would have an image. Let's say this is 1, 2, 3, and 4 on each one. Then you would have a number code, or you would have a picture code. There was a reference that I used for the. See if I can find it. I'm not too sure where it is. In Skyrim, in the temple. I'm not too sure if you've played it or if you've heard of it. A lot of people might not have played it or heard of it, but in Skyrim, there's a temple, and to cross a bridge you have to rotate some pillars. So you could have, potentially you could have 3 of these, so you could make another 2, and then you'd have to match certain symbols with like maybe kind of a pictogram on the floor or something on the wall, and that would like unlock a door or progression path. So this is the fundamentals behind it. This is how it works. This is a really good way of setting it up. But I hope it helps. If you like the video, then please hit the like button. It helps me out. If you want to help other people learn, then please share it with them as well to help them learn. If you subscribed on YouTube, which supports me in the long run, then please, you can join me over on Discord, where you can ask questions, get to know the community. There's a lot of people on there, very talented. Everyone's always willing to help each other. So yeah, like it, share it, subscribe. I appreciate all your support. You can help me out over on Patreon by signing up to my Patreon account. Stop trying to get attention, tiny dog. You can subscribe to me over on Patreon. You can support me on PayPal. So there's different ways you can support me. A lot of people have asked how, but yeah, please read the description of the video, and I'll put the links that are necessary in there for you. So hope you liked it. Take care, stay safe, and I'll see you all in the next one. Bye bye for now.